It might all sound a little bit removed from your everyday life, but it is really not. There are lots of everyday applications that are based on that the thermodynamics exists, and that we know how to use thermodynamics appropriately to accomplish different things. For example, something as simple as welding. This is the reaction of acetylene with oxygen, and you produce CO2 and water. This reaction is hugely exothermic. A lot of heat is released with the combustion of acetylene, and so high that the flame reaches around 3000 degrees, which is enough to melt most metals. This compound here, ammonium nitrate, is what you have inside the instant ice packs. You know those ice packs that you can just thumb them, like break them like this, and they get cold? Well, they are based on the reaction that if you have ammonium nitrate in solid state and you dissolve it in water, you produce ammonium ions and nitrate anions, so you liberate the ions, and that reaction is slightly endothermic. So it needs heat from the surrounding to happen, but not a lot. And where does that heat comes from? Well, it comes from your hands, from your body, wherever you're applying the ice pack. It comes from the heat of your body. So it has it's a bag that contains ammonium nitrate, and it has inside a small plastic bag that contains the water. So when you break when the pack is thumbed, when you break that inner bag, the ammonium nitrate mixes with the water. The endothermic reaction happens because there is enough heat in the surrounding, for example, from your hands or your shoulder or wherever you're applying it, for the reaction to happen. Finally, I wanted to bring this application, although I think that I am stretching the definition of everyday application to the limit. I don't think we are quite there to call space travel as an everyday application of thermodynamics. But we have been using thermodynamics and the power of thermodynamics to send people into space for decades now, using hydrogen as our fuel. And for example, the Getting Back to the Moon missions, the Artemis mission, will carry 2,500 cubic meters of supercool liquefied, so it's easier to carry, hydrogen and oxygen. And that fuel mixture produces a very good amount of energy. The reaction of hydrogen liquid and oxygen liquid to form water in gas, in this case in gas form, releases 241 kilojoules per mole of hydrogen. Hydrogen has an excellent enthalpy of combustion and a very low density, so you can pack it really well. So that hydrogen-oxygen mixture produces 13.4 megajoules per kilogram of energy, and that's the highest energy per kilogram of any other chemical fuel. And with the advantage that the product you make, water, once you liquefy it, can also be used as it's a useful byproduct. You can use it as part of the mission.